We're going to run through some of these integration problems, and we'll show you the technique of substitution. This gets a lot of things done. Now, okay, we'll start off with this one here. If it just looked like this, we would be done, because we know that that would be a negative cosine of u plus a constant. But it doesn't just look like that. It has a 5x minus 3. So what you could do is a substitution. You could say, oh, well, my u is equal to 5x minus 3. My du is 5dx. So 1/5 of du must be dx. Now, that means that we can transform this integral to become this. Sine of u, and I have times 1/5 du. So that's 1/5 sine of u du. So I'm ready to go then. I know this is going to be a negative cosine of u plus a constant. So it's negative cosine of u over 5. The last step is to get x back into the problem, back into your answer. U was 5x minus 3, so this is a negative cosine of 5x minus 3 over 5 plus a constant. So that's how you can use substitution. You have to be creative with your substitutions, but there's certain things to look for. And you'll as you practice, you'll start to see some of that. Okay, let's do another one here. That was so short. Okay, here we're looking for this form. If we see u to the n du, we know that that's going to be u to the n plus 1 over n plus 1 plus constant. So what you look for is sometimes one part of the integral, one factor within the integrand, is in fact the derivative of the other. And you'll notice that's the case in here. The derivative of x to the third plus 2x is 3x squared plus a 2. It's right there. In other words, this portion is du. This portion over here is u to the 4th. So I really have this integral u to the 4th du. So it becomes u to the 5th over 5 plus a constant. So my u was understood to be x to the 3rd plus 2x. So here, and that's to the 5th power. So here's my answer then. So I kind of just singled this out. I didn't do a physical change in variable. I just realized that I had this form, u to the n du, with the u being equal to the x to the 3rd plus the 2x, du being 3x squared plus a 2 times the dx. So there it is. And notice this is where we're using a differential notation, the differential of u. Okay, seen that before.